Hello and welcome to our webinar, Iselux, the clear solution for luxury foam. I'm Alice Miles, Technical Manager for Personal Care Customer Technical Support, based in our labs in the UK. Thank you for joining us to hear about new data for one of our hero products, Iselux. Today I'll be giving you an overview of the product range, talking about benefits in terms of formulating and foam properties. I'll be presenting new data on rinsability and new data on dye washout, and I'll finish off talking about Iselux with sodium benzoate. Iselux, sodium lauryl methyl isethionate, or SLMI, is an extremely mild anionic surfactant used in formulations as a primary or secondary surfactant. It's a unique proprietary technology. It works well with chelants such as Natural Quest E30 to produce clear formulations. It readily builds viscosity with salt when combined with amphoteric surfactants. It provides luxurious foam with a very fast flash foam and easy rinsing. It improves deposition of cationic actives and silicones, resulting in improved conditioning and reduced dye washout. It has enhanced hydrolytic stability compared with sodium cocoyl isethionate, enabling a broader formulating pH range. It's also readily biodegradable and 80% naturally derived, and it's easy to formulate with excellent water solubility, and clear or opaque formulations are possible. So we have a few different products underneath the Iselux umbrella. There are two different inky names available, sodium lauryl methyl isethionate and sodium cocoyl methyl isethionate, whether you want China approval or Leaping Bunny approval. And these are both available as solid flakes for hot process formulations or as liquid solutions for hot or cold processable systems. Then we have used Iselux to create performance concentrates for specific applications. So Iselux SFS SB is a just add water cold processable blend, allowing you to create simple frame formulations. And Iselux SLC allows cold processable opaque structured liquid systems with up to 20% of oil. And Iselux Ultra Mild has been optimized for baby and facial formulations where very mild formulations are needed. Again, just a just add water concept that is cold processable. So we can see that since the launch of Iselux in 2009, formulators are choosing to use Iselux in the products due to the benefits it can bring to their formulation. So this is data from Mintel GMPD showing the number of new products launched globally containing sodium lauryl methyl isethionate and sodium cocoyl methyl isethionate. And we can see a rise in the numbers each year, a little dip in 2023 due to global market conditions. And we can see the influence of the additions to the product range transferring to new products being launched on the market. We can see SCMI appearing as a new inky in 2020 after the launch of Iselux SCMI, and it settles at around 5% of the total number of products launched globally. So let's look at some of the benefits of Iselux in more detail, starting with clarity and salt thickening. Iselux is similar to SCI, but the small change in chemistry means that Iselux is a lot more water soluble. It will dissolve much faster and will produce a much clearer solution. So we can see here that a 10% solution is crystal clear, whereas a 10% solution of SCI is opaque. For clear formulations, SCI can only actually be used at about 1 to 2% in combination with other surfactants. The Iselux solutions are also very flowable, whereas SCI solutions start to become quite viscous. So SCI is more suited to solid applications such as bars and pastes if it needs to be used at a higher level. And on the right hand side you can see that Iselux is clear over a wide range of pHs as well. A chelating agent should be included with Iselux to ensure that the formulation is clear. Natural Quest E30 is an ideal choice, and this is already included in the liquid grades. Iselux can be thickened with salt when it is combined with other surfactants. We can see in this top graph, in the blue line, how Iselux combined with cocamidopropylbutane, or CatB, at 6:3 ratio thickens with salt. It's not that high of a peak and it's a little bit narrow. It can be easy to go over the salt curve with small changes in the formulation. However, it really comes into its own when it's used in combination with other anionic surfactants. For example, here in orange, when Iselux is combined with Nansa LSS 38AV, our alpha olefin sulfonate, and with the CatB, you can see that it has a very high peak viscosity. The peak is a good width, it's not too narrow, and it's using a reasonable amount of salt to thicken it, so only around 2.5% of salt is giving 12,000 centipoise. Nansa LSS 38AV on its own with 3% CatB, the dark green line on the far right of the graph. This is taking a lot of salt to thicken, so we have a really good synergy between the surfactants, and the Iselux is reducing the amount of salt needed to thicken that AOS system. In contrast, in the lower graph, in the blue line, we can see that SCI and CatB on its own is requiring more salt to build. The purple line then shows that it does shift the salt curve when it's combined with AOS, but it's not shifted it to as low salt as with the Iselux. And using a lower salt level has advantages in terms of mildness, being able to formulate clear formulations with cationic polymers that remain stable, and less corrosion to equipment over time. So the most important part of a surfactant, how it foams, and then how fast that foam is rinsed. Now we know that one of the main reasons Iselux is so popular is because of its excellent foam characteristics. So here's some data to show how it compares to sodium lauryl sulfate, SLES, and sodium cocoyl isethionate, SCI. We chose those two because everybody would like to know how it compares to SLES, and if it can replace SLES as a sulfate-free alternative, and because of the similar chemistry to SCI. There's just a methyl group added, but this changes the foam characteristics a lot. So firstly, we did a triangle test with 15 panelists to see if the difference between these surfactants can be detected, which it can, when it's used in a blind study. Then we did a panel study, again blinded, to find out what the differences are. We found that Iselux is easier to start foaming than the other two, with a faster speed of foaming and a higher amount of foam. The visual appearance and creaminess of Iselux is similar to SLES, with a mixture of small and large bubbles, whereas SCI has much smaller bubbles. It's more suited to applications where a tighter bubble size is required, maybe facial cleansers where a lather is needed. And we can see that the SCI and Iselux were faster rinsing than SLES, and I'll come to that again in a minute. As well as the excellent foam profile as a primary surfactant, Iselux also has a lot of benefits when it's included as a secondary surfactant with other surfactants to really boost the foam and change the bubble size. So here we have a range of simple formulations made with and without Iselux substituted, so that we can see the benefit to the foam, and also there's some other formulation benefits as well. So even using a very basic SLES and CatB system, there can be a benefit from substituting 2% active of the SLES with 2% active of Iselux. So that's the only difference between these two formulations. The co-surfactants and everything else remains the same. There's the same total active surfactant level. It's just a small amount of Iselux. So it's a minimal impact on the price, but it's got a really big benefit on the foam, as you can see in that photo on the right. There's much more foam produced, and actually the feel is nice and soft as well on the hands. It also gives a viscosity benefit, so a smaller amount of salt was used, as you can see on this table, and a higher viscosity was achieved. Another low-cost system using alpha olefin sulfonate, our Nansa LSS 38AV. In this case, 3% of active of AOS has been substituted with 3% active Iselux, and this has resulted in a faster foam. AOS can be a little bit slow to foam. It gives a larger foam volume and a faster rinsing speed, and it's also requiring less salt for thickening compared to the AOS system, similar to what we discussed earlier. For a natural system with APGs, a large amount of surfactant is needed to create quite a small amount of foam that we can see on the left-hand picture. But by including 2% active of Iselux and reducing the other surfactants, it really boosts the foam, and actually the naturality content is even higher. It also speeds up the rinsing, which also is helping with the sustainability aspect. And finally, looking at our amino acid surfactant, sodium lauryl glutamate, there's a boost in viscosity and a boost to the foam volume when half of the GLT has been substituted with Iselux. So we have a full range of formulations with different surfactants where there's a benefit from substituting in a small amount of Iselux. So even when you're not creating a formulation from scratch with Iselux, adding Iselux to a formulation, swapping a small amount of surfactant for Iselux can really have a big benefit. Now, I've talked a bit about faster rinsing with Iselux, and we've generated some data to quantify this. This is looking at a 10% active surfactant solution that has been applied to mannequin heads and lathered up, as you can see in the photos. Then the time taken to rinse the head until the hair is bubble-free is measured. And we can see that the Iselux system takes half the time to rinse compared to the SLES system. So fast rinse is an interesting topic now from the point of view of low hot wattage usage and for time saving. So there are benefits for consumers in terms of saving time in busy schedules or dealing with wriggly children or thinking about their energy bills. Benefits professionals in salons, whether they're hairdressers or dog groomers. And benefit for the environment in terms of less hot water being needed to be used. So Iselux is ideal for shampoos as it has a mix of large and small bubbles. It creates a large foam volume with a fast flash foam and rinses easily. It's also ideal for shampoos as we've shown it can enhance the deposition of cationic actives and therefore increase the conditioning effect on the hair. So when a conditioning shampoo is used, a coacivate of conditioning agent is deposited on the hair when the shampoo is diluted. In real life usage, this dilution happens by applying the shampoo onto wet hair. Here we are measuring in a solution how a coacivate is formed with Iselux plus guar versus with SLES plus guar. So you take a surfactant solution containing cationic guar and dilute it and measure the clarity. A reduction in clarity means an opaque coacivate has been formed. So Iselux has a wider area of coacivate formation with dilution than SLES. So this means that when a shampoo containing guar and Iselux is diluted, more guar will be deposited on the hair when the shampoo is put on the hair versus the equivalent shampoo with SLES. And we can visualize this effect on white wool swatches. So the swatches are washed with solutions with the cationic guar, and then an anionic dye is applied to visualize where the conditioning active has been deposited. So the control switch with no cationic guar is still white. With the SLES with cationic guar, you can see there's been a small amount of deposition because the swatch is now a pink colour when the dye has been coated on top. And on the right hand side you can see that Iselux has deposited more of the guar than the SLES because the red colour is more intense. And we can see that this translates to a reduction in combing force. When Iselux is used as the primary surfactant in a shampoo on the right hand side, we can see a greater reduction in combing force compared to the equivalent shampoo containing SLES. This means the hair will be easier to comb and there will be less damage to the hair as the comb will glide more easily through the hair. Alternatively, you could reduce the quantity of actives and still have the same amount of conditioning as with an SLES equivalent. There are also visible improvements from improved deposition of actives and even when Iselux is included as a secondary surfactant. So this is a conditioning shampoo chassis based on AOS. When Iselux isn't included, the hair tress shows more static on the left-hand tress, and then on the left-hand side of the mannequin head, the hair is frizzier and less smooth. whereas if you substitute 3% active of AOS with 3% active of Iselux, then on the right hand side of both of these pictures you can see there is less static, the hair is smoother, the fibres are more aligned and there's less frizz. Another benefit of improved deposition of actives can be for dye washout. So this is a new study where dyed yak hair switches, so yak hair is naturally white, so it will show the dye more. These were washed 30 times, either with a shampoo containing SLES silicone and guar or a shampoo containing Iselux silicone and guar. The colour of the switch was measured before and after the 30 washes with a colorimeter, and the colour change, or delta E, was calculated. You can see from the graph that the colour change was reduced by half when Iselux was used as a surfactant in the shampoo compared to SLES, due to the deposition of actives that are protecting the hair dye washout. So lots of formulators these days want to use sodium benzoate as a preservative, and this often dictates what pH they want their formulations to be. So how does this relate to Iselux? So we said before that sodium cocoa isethionate has a very similar structure to sodium lauryl methyl isethionate, but there is this additional methyl group. This methyl group is very important as it gives some steric hindrance to the ester linkage. In SCI, this ester group is prone to acid hydrolysis, which cleaves the ester linkage and releases the free fatty acid. This can cause cloudiness and all sorts of instability in the formulation. Eventually, this will happen to all esters when they're in an aqueous solution, but it is sped up if it is at a low pH or if it's at a high temperature. So we can see this effect in these graphs. So the SCI is in solution at 45 degrees, and you can see that the activity reduces over time because the molecule is falling apart because it's being hydrolyzed. You can see that at pH 3.5 the activity drops very fast. At pH 4.5 it still drops, and around pH 5.5 to 6.6 it starts to stay steady. Therefore, we can recommend a formulating pH for SCI around pH 6 to 8. On the right hand side with Iselux, the methyl group is preventing as much hydrolysis happening. At low pH, here at pH 3.5, we can see that the activity is dropping. And at pH 4.5, it's still dropping a bit, but at pH 5.5 and above, the activity is constant. So we can be reassured that it will be stable in a formulation from around pH 5.5 to 8.5. It does depend on the quantity of surfactant, the quantity of water, if the formulation is clear or not, and therefore if the hydrolysis is visible. But generally, we would suggest a pH above 5.5 or even more like 5.8 would be good for Iselux formulations. So where does that leave us with sodium benzoate? We know that the protonated form of sodium benzoate is the active form that protects against microbial contamination. In aqueous solution, the pKa of sodium benzoate is about 4. Therefore, a low pH is normally recommended. We wonder if Iselux will be out of range of the recommendation for sodium benzoate, but surfactants can shift the pKa higher. This is a study looking at apparent pKa as the surfactant concentration is increased, and we can see that for SLES and especially for Iselux, the pKa of sodium benzoate can be shifted higher. This results in a higher efficacy than you might expect at a higher pH. So challenge testing showed sodium benzoate was still effective at pH 6.5 in an 8% solution of Iselux. So don't rule out Iselux based on the recommended pH formulating range just because you want to use sodium benzoate. Try putting your formulation at a slightly higher pH and see if you still pass the challenge test. So to wrap up this webinar, Iselux has a luxurious foam profile and fast rinse. It gives improvement in foam quality even as a secondary surfactant. The foam is different from SLES and SCI and has a faster rinse than SLES and SCI. Iselux gives enhanced deposition of cationic actives. This results in a reduction in wet combing force compared to SLES. It gives visible improvement in hair alignment even as a secondary surfactant, and it can result in less dye washout than SLES due to active deposition. And there are benefits when formulating with Iselux and sodium benzoate. It increases the pK of sodium benzoate, and therefore it's possible to achieve effective preservation at a higher pH with Iselux. We have a wide number of formulations showcasing how to use the Iselux range, and here are a few examples from our new formulation kit, Be Unique in Wonderland. So many different formats and textures can be created with this range, and we have some samples of these available for you to try. So please get in touch with us if you would like samples of formulations or with any of the Iselux products that we have mentioned today. We would love to hear from you, and thank you so much.